how fast you're moving pitching up and down. Okay, so the time that you take to complete one full cycle is simply 2 pi over this omega. Okay, so this is how fast you're moving, and of course from omega we compute our k, right? Omega b over u. Okay, so give me the velocity. The velocity is this guy, this u. Cosine gives you tangential, sine gives you normal, but it's down, so it's negative. And there is the alpha dot term. So this component is at any point. This component, this first component is at any point. Plus the second component, due to alpha dot, now depends on the difference from the point to the hinge. So this is from here. Yeah, sorry about that. So this is A. This guy is from the hinge. This is U. This is alpha. And that's it. This is a distance, a point x, at which we need to compute the normal velocity due to alpha. Simply, it's omega r kind of thing. So your angular speed, alpha dot, times the distance. The distance is x minus ab, and it's downward, so this is negative. You got the normal speed. We need the angle of attack, alpha, is simply this guy divided by u. So alpha at the 3/4, we substitute x by b over 2. So alpha 3/4 is alpha, approximately. Sine alpha is almost alpha. Plus alpha dot b over u 1/2 minus a. This is alpha 3/4. Okay. So if I want to substitute, this is a alpha sine omega t plus a alpha, I took it as a common factor, omega b over u, this is k actually, 1/2 minus a, and cosine omega t. This is alpha 3/4 at any time. If you have a question, just stop me, but this is straightforward algebra. Even though if you have a question, stop me, please. The acceleration, we just differentiate this guy. So the acceleration, if this is, like I said, if this is almost alpha, if we differentiate this guy, we have, so this is negative u alpha dot, right? Negative alpha double dot x minus ab, and half chord, meaning x equals 0. So a half is negative u alpha dot plus alpha double dot ab. You take this immediately and multiply by pi rho b squared, you get the non-circulatory. I'll not do that, I'll do the other one. So the circulatory lift as a function of time is, again, let's look at that, please. Let's look how we construct it. So always rho u b squared, right, times your lift coefficient. This is how we get the lift. The lift coefficient is 2 pi alpha 3/4, right? Alpha 3/4 here is alpha 3/4, so it's a alpha times this bracket sine omega t, and plus here k half cosine omega t. So all what Tudorson does is, well, we multiply this by the magnitude of Tudorson function, and we modify the phase here. The same, it doesn't matter sine and cosine. They're the same, multiplied by the same amplitude and modified by the same phase. It doesn't matter. Okay? So this is your circulatory lift. Add to it the non-circulatory to get the total lift. Any question about that? Any question, please? I'll give you some time to write here until I erase this. So as you can see, we're heavily relying on the fact that it's cosine and sine. Because I get into the cosine and modify it from inside and multiply the amplitude by a factor. If it's not cosine, if it's t squared, for example, how can I modify the phase? You know, there is no means of doing it. So this is the problem here. Because Tedderson, from the beginning, he was interested in the harmonic motion for flatter application. So the next question that immediately arises is, what if not harmonic? Okay? Any question, please? So far? What if not harmonic? So, for example, if I have something like this, well, we don't have luxury of space, so do this. If this is alpha, this is your input, right? If it's sine and cosine, I'm done. But if it's not, maybe something like, you know, well, if it's periodic like this, then we have a solution. How? First of all, let's see what are we expecting. How we are expecting the lift to behave. So this is an input to a dynamical system. Here is your lift. Of course, I'm talking about the circulatory. I don't care about the non-circulatory because it's easy. Just get the acceleration out of that and multiply by the added mass. So this guy, at the beginning, there is some transient which Tedderson cannot predict. Tedderson is the frequency response. Frequency response is the steady state response due to a harmonic input. Steady state. So even if this is harmonic, even if I'm giving perfect sine and cosine, the very first few moments, Tedderson cannot predict. Okay? So assume that this is sine and cosine for the moment. Well, the transient I cannot predict anyway. But after the transient, there will be a pattern that is pretty much follows the input if it's linear system. Okay? This is the steady state pattern which Tedderson can predict. Steady state, but of course it's time varying because the input's time varying. If it's perfectly sine and cosine, if it's perfectly harmonic motion, well, here is what we did. If it's not, luckily, we already know from mathematics that any periodic function, periodic nice function, by nice, I'm not rigorous enough here, but nice I mean integrable actually. Integrable function, so a continuous function is a nice function, is an integrable function. A function that has finite number of discontinuities is also integrable. So any function of engineering relevance that mathematicians are not trying to make up things with will be applicable here, that's fine. So a periodic nice function can always be written as sum of sines and cosines, right? Alpha, 3/4, whatever the function name, can be always written if it's a t squared like this and then coming back over and repeats itself over a period. So this is t here, 2t, okay? So there is a fundamental frequency, omega is 2 pi over this t, that over which it repeats itself. You can write this function as a sine and cosine. So a naught, some constant term, which is the average of the function, plus summation n1 to infinity, some coefficient cosine n omega t plus Bn sine n omega t. What's this omega? We said omega is the fundamental frequency, 2 pi over t. Okay? Anybody remembers the name of this series? It's very famous, right? What's the name? Fourier series. Very good. This is Fourier series representation of alpha 3 chord. How can we get these coefficients?